MicroPython on Pico. We'll have a demo. Let's talk about this a little bit. So MicroPython, it wasn't the first project like this, but it's really doing a great job. It's for embedded micros, and you can run it on a host machine. Can't go really small because you need about 256K of code space, so it's not for tiny microcontrollers, but still, it's pretty small. The current embedded.fm podcast has a really interesting example of using MicroPython on a current episode right now too. What I liked about it when I looked at it is it really does a great job of exposing the embedded environment things in a really Pythonic manner. And what version of Python is it? It's 3.4 plus some of the stuff in later versions of Python. They do have docs that describe the Delta versus C Python. There's a few things they had to shoehorn a bit. They do have pre-built images for the Pico hardware, which is what I have here today. It's available for a lot of platforms. So Raspberry Pi came out with this a couple years ago. They have their own CPU, which is a dual core CPU, 2 meg flash, 256K of RAM, so it's got lots of heat. It's got lots of I/O, lots of embedded resources on there. This drawing is a little bit small, but basically a bunch of pins on there with a lot of different peripherals that can be used on there. Serial, ITC, SPI, PWM, ADC, all kinds of things. And there is a wireless flavor of this, and I looked at it, and I think they do a pretty nice job of exposing BLE and Wi-Fi, Ethernet in a Pythonic way, but I haven't played with that myself. And there's now a Pico 2 with that came out this past year. Toolchain, you can spend a lot of time fooling around through toolchain in the embedded world. Here, there's a ROM bootloader, so there's a button on there. You can power it up with that button, and the bootloader will come up, and it'll show up as a mass storage device. And then you can go grab a MicroPython image, save as, right on that, and then reboot, and you're running the MicroPython image. You can do bare metal C or other things, but why would I do that if I could do Python? The documentation, when I read it last year, they didn't tip me off to the one secret. One secret you need. mpremote is the tool to use to work with it from your host machine. You could, of course, do some prototyping running MicroPython on your regular host machine. A few references are good to keep in hand when you're working with this. So the mpremote documentation, the MicroPython documentation, the section on libraries, standard libraries, the MicroPython specific ones, port specific nuances, but again, even the MicroPython specific stuff, they try to keep it common across the different targets. The Pico documentation itself and the microcontroller is useful, like to know what pins you can use for what and that sort of thing. And the Pico has a Python SDK document, which is kind of the document to describe how to get going with MicroPython here. mpremote, you can pip install it. One of the things I found useful is on a Windows machine, I was trying to figure out how to get a ANSI terminal, and I spent some time looking into it, but I found mpremote first, and that gives you a nice correct console emulation, terminal emulation. You can use mpremote because there's flash on here. There's a flash file system. So you're embedded, you got a flash file system, you can use mpremote to push and pull and do all the file system kind of things remotely from your host. And if you drop a main.py on there, power up, it'll run the main.py automatically. You can add multiple files on there, import locally, all this kind of stuff. All right, so let's do some demo. So I just have this Pico plugged into a solderless breadboard here. There's an LED that's soldered that comes on the board itself. And I went ahead and hooked up a speaker, a momentary switch, and an LED which is pointed the wrong way. I don't know if I have the plus and minus swapped out there, but we're going to find out. All right. 90 minutes. it's not running on my laptop, it's running on this little tiny embedded microprocessor. I think there's even help here. There's even help. All right. More can you ask for? So let's blink that LED that's on here. So there's that one drawing I showed. They show you the LEDs on what they call GPIO 25. So we're going to try that out. So there's this machine library has some of the embedded type stuff. So we're going to import something to work with pins, and I didn't use signal, but let's go ahead and import it anyway. And PWM. Let's see, LED equals pin, and then so it's run the GPIO 25, and IO pin, general purpose IO pins can be used in different ways. So we're going to say how we're going to use it, which is as an output pin. Let's check the value. Right now it's 0. Let's change that LED value 1. I don't know if you can see it back there. Can you see it? Yeah, it's a little bit green. All right. Let's use a big LED. So I've wired up a bigger LED on a different I/O pin. It's on 16.
Got an F in there.
Thank you. Yeah, holler at me when I make typos. I will make typos. Yeah.
A big F in LED.
Hey, okay, I got the plus and minus right. So got this bigger blue LED, which was from some leftover from I don't know what at home I found. I'm gonna import time, and I'm gonna do a while loop because this is the kind of little 3-liner thing that's kind of useful sometimes to do. Oops. Turn it on. I'm gonna do sleep. 10th of a second. Turn it off.
So this is an mpremote console.
Yeah, so mpremote is providing the terminal emulator. So, and again, it's cross-platform. So that's one, Python provides the cross-platform ability that Java promised us in 1995, and I haven't seen deliver yet. So, but it works in both Windows and Unix. I haven't tried Mac OS, but I'm sure it's going to work just fine there. So I'm running an interactive shell that's running on the MicroPython on this little tiny chip right here. It draws less power than this laptop, by the way. That's one of the things to think about. And so now the LED's blinking because I'm just running. So a quick little while loop to interact with your hardware, make sure you got the right thing hooked up is nice. And we'll stop it. Oh, I stopped it when it's off. All right. And then let's see. Speaker. There's a little amplified speaker. There we go. So I got that plugged into a pin, a little amplified speaker, so we can make that buzz. So I imported that PWM library, so we'll use that to cheat a little bit. Type. Can I type? So on pin 15, I'm going to set it up for PWM with frequency 262. In case anybody's got perfect pitch.
262 hertz?
Yes.
Low.
So, oops. So there's a couple different ways you can specify the duty cycle on the PWM output, and this one's going to do a 16-bit unsigned value, so it's like 0 to 100%. I'm going to keep it down pretty low. Let's see. Do I have it plugged in? Is it turned on? All right. Got the speaker off. All right. That's annoying. Turn that back off. Oh, we can make it louder. Oh, all right. So, I like to have hardware hooked up to my Python. And then the other thing I brought is a momentary switch, new old stock from the Ukraine, and that's plugged into another GPIO pin. So let's do key equals pin. That's on
What was that about Ukraine or UL stock?
New old stock from the Ukraine.
New old stock from Ukraine.
Yeah, I bought this off of eBay from a vendor in the Ukraine a couple years ago. It's a nice it's a telegraph key, and it's built like it was meant for people to use in the field. So
I thought microcontrollers would flow in the other way these days.
Let's see, so we want this pin to be an input pin, and then the other thing I'm gonna do is I'm gonna make it a pull-up, so that inside of the chip, they have the option to attach a pull-up resistor, so that net is gonna be pulled up to the positive rail, and then when the switch across there is closed, that'll sink the current back down, pull that node back down to 0 volts. So it's gonna be an inverted signal, but the signal library will handle that for you if you want to abstract that out. But I'm not gonna demo that today because I'm trying to keep it quick. So let's see, key that value. So it's 1, I'll close the key. 0, all right, that works.
Cool.
Let me do a quick loop.
Very cool.
What should we do when we close the key? We'll turn the big LED on. And we'll make a racket. What was it, 1,000? We like 1,000? Right. Else, oh my gosh, we got logic in here. If they've got the switch open, I'm going to turn that off. Command line history is often useful too. All right, so what's that do? All right.
Morse code transmitter.
All right. Now, let's use it. So let me get out of this, and it's the same exit as minicom or whatever, the same exit character. Then let's see. I do have a main.py written already. Font's a little small, but it's basically what we're doing. We'll do, let's see, Python 3, remote, file system ls, and then colon is the prefix for the remote file system. And it's empty on there, so we'll do, let's see. Copy that there. Okay. Turn off the power. Turn on the power. My volume's a little low. Fix that. So it's just by powering it up, it's automatically run the main.py on there, and then yank the power. Doesn't work anymore.
So,
battery pack. No host computer anymore. Now it's an embedded system, right? Because it's put in a box, hide it all.
so you created that main.py by taking your history from the terminal?
In this case, I rewrote it, but let's look at it real quick.
Oh, okay.
So it's just gonna, it's start up, it's gonna sleep for a second, and it's gonna set up those output pins and not input pins, and it's gonna run that while loop. That's all it is. So, but you know, again, you got a file system there, so you can break up your project into a bunch of files as appropriate, libraries, all that kind of stuff. There's some micro libraries, which are kind of MicroPython versions of some libraries, and other people are writing libraries and all that kind of stuff. But again, on the device, this is a pretty impressive chip for what it is. They sell it for $4 on the board, mounted to a board already. They promise production until like 2035 or something like that.
And is that main.py, will it remain there if you power off?
Yeah, it's on a flash file system, so we'll do that. So turn off the power. Power's off, turn it back on.
Wow.
Starts responding again after a second. So since everyone here knows Python, you're now embedded software developers. So
Yeah.
just put some main.py on one and add that to your resume. So that's it. I have a few of these to give away, so we're going to do that too. Anything else, Jeremy? Or?
I got the script.
All right, I'm wrote the demo.